Hi, this is probably the last lesson of the year. It's on pH. And the homework is page 167 to 170. And I want you to look at page 165 for some formulas. All right, so before we get into the problems, pH is a measurement of how acid or basic something is, how acidic or basic. So the scale goes typically on a scale of 0 to 14, with 7 being neutral. All right, so water is pH 7. Water is neutral. It's neither acid nor base. The scale at the numbers at the bottom make it acidic. So when you're at 1 or 2 or 3, those are low acids. Okay, again, these are pH. So if you say the pH is 1 or the pH is 2, then it's an acidic solution. If the pH is 13 or 12 or 14, then it's a strong basic solution. Okay, so anything below 7 is acidic, anything above 7 is basic. So even if it was 6.99, it would be just slightly acidic. If it was 7.01, it'd be slightly basic. All right, and it goes all the way down and all the way up. So in order to do problems, we need to know a few formulas. So as you do the homework pages, look at this chart on page 165. And what this chart will show you is how to move from the pH to the pOH and the hydroxide concentration and the hydrogen concentration. So it's a map where you can move from one corner to the other corner. All right, so here's a few things. So if you have an acid, remember acids start with hydrogen, like hydrochloric acid or nitric acid or sulfuric acid. Okay, remember they always start with hydrogen? So if you have a 1 molar solution of HCl, then the H plus concentration, okay, the molarity of the hydrogen is 1 molar. If you have a 0.1 molar, HNO3 solution, then the hydrogen concentration is that same molarity. So whatever the molarity of the acid is, the molarity of the hydrogen is the same, because as the acid breaks apart, it breaks apart into hydrogen ions and whatever the anion is. And so if this is 0.1, then as it moves over to the right, this is also 0.1. So what we're gonna do is to calculate the pH, we're gonna do the negative log of the hydrogen ion concentration. Negative log. So if you take a 0.1 molar solution, and on your calculator you go negative log 0.1, then the pH comes out to 1. Okay? If you had a 0.01 molar concentration, then the pH would come out to 2. Okay? And so you're going to have to use your calculator to do log functions, log base 10. All right? And so as you move through the problems, make sure you look back on page 165. All right, so let me do an example problem for you. Let's say that so the homework on page 167, you're just gonna watch these videos and get a sense of literally what pH is. And then when you do page 169 and page 170, you're gonna have to do some calculations. So if you had, let's do an example problem, okay? Similar to the homework, but not an exact problem. Let's say that we had a hydrochloric acid solution that was 0.02 molar. Then what we want to be able to do is move to the four corners of the flow chart here. So we want to be able to go H and pH and then pOH and OH. All right, and all the way around the circuit. So with one number, we can get all four numbers. All right, so I'm gonna run through how to do that really quick. All right, so if you're given the molarity of an acid, then remember the H plus is the same. So this would be 0.2. Okay, that's our starting point. So let's move down and around until we get all four numbers. So the next thing we do is do the pH. So the pH is the negative log of the hydrogen concentration. So if you do the negative log of 0.2, let's plug it in my calculator here. So negative log 0.02, it comes out to 1.69. Let's round that to 1.7. So we're gonna say the pH is 1.7. Okay, now the pH and the pOH always add up to 14. Okay, so pH plus pOH is always adding up to 14. So if I want to get pOH, it's just 14 minus pH. So 14 minus 1.7, so 14 minus 1.7 is 12.3. Okay, so the pOH, which is more of a measure of the hydroxide concentration or how basic it is 12.3. Okay, and then finally to get to the hydroxide concentration, what you're doing is inverse log. So to get hydroxide, it's 10 to the negative pOH. All right, and it's on the formula sheet. You just got to look at the formula sheet. 10 to the negative pOH. So I'm going to go 10 to the negative 12.3. I'm going to go 10 caret negative 12.3, and it comes out to a really small number. So don't forget the exponent. So it's 5.01 times 10 to the negative 13, and that's molarity. All right, so what you want to be able to do is move around the circle to get all four numbers and use page 165 to help you. All right, so this is 5.01 times 10 to the negative 13, and there we've moved around the circuit and got all four numbers.